Hi, my name's Robin Linacre and I'm a data scientist working at the Ministry of Justice. Today I'm going to be talking about the Ministry of Justice's Data First project, which aims to unlock the potential of the wealth of data that's created by the department. I'll start with an introduction to the project and what we're trying to achieve, and then the main focus of the talk is going to be about how we're using data linking and data deduplication to improve the quality of the data. And then I'll talk a little bit about how we're making the data available to researchers. So let's start by introducing Data First. It's an ambitious project which is led by the Ministry of Justice and it's funded by Administrative Data Research UK via the ESRC. So what are we aiming to achieve? Well, we know that a lot of people have difficulty in gaining access to de-identified crime and justice data. So the Data First project aims to unlock the potential of the data by making de-identified data more easily available. The idea is that we want to inform policy and knowledge in a way which maintains the confidentiality of individual users of the justice system, but at the same time helps to improve justice. And we understand that the data needs to be confidential yet granular enough to tell us about aspects of structures and processes that enable us to protect the vulnerable. In terms of scope, some of the key data sets are from the criminal, family and civil jurisdictions. And we understand that many of the key research questions involve understanding links between different parts of the justice system, so journeys through the justice system or repeated use of the system. And that means that data linking is a core part of the project, both internally and with other government departments. And we're then making data sets available to researchers through the Office for National Statistics Secure Research Service. And to make this a success, we're working in partnership with independent expert academics to facilitate and promote research in the justice space, and in particular, to help us fill evidence gaps. We're hoping that this leads to a sustainable body of knowledge on the justice system. And we're particularly interested in things like interaction between services. So, for instance, a victim of domestic violence may be using more than one part of the justice system to help protect themselves. And in the absence of linked data, there are challenges for researchers in being able to build up a joined-up picture of how these services are working together. So, by improving the data and by working in partnership, we're hoping to drive real progress in tackling social injustice problems. And this hopefully helps to clarify why data linking is of central importance to the project. So I'm now going to move on to talk in more detail about the data linking and how we are trying to make this as accurate as possible and as useful as possible. So the key challenge here is that justice data is collected in a range of different administrative data systems, but there are no unique identifiers that allow linking between the different systems. And we therefore need a process of data linking if we want to track individuals across data sets or across time. So by data linking, to be clear, I mean a process of statistical estimation where we try and use the data to work out who is the same person across data sets and across time. We tend to use personal identifiers such as the person's name and date of birth for the process of data linking. But this information is only of interest in establishing the link. Once the link is established, this personally identifying information is removed before the data is made available to researchers. So we faced a number of technical challenges associated with data linking for the Data First project. And the biggest of this is just the scale of the data. Data linking is nothing new, people have been doing it for years, but it's unusual to need to link data at the scale of the datasets we have at the Ministry of Justice, which is sort of tens of millions of records. And the fundamental problem is that to establish a link, each record must be compared with every other record, which means, let's say you have an input dataset of a few million records, you have potentially trillions of different record comparisons, and that's just computationally intractable. And to make matters worse, we need to deduplicate many of our datasets, which essentially means that you can't stop when you find a match, because if an offender returns to court, for instance, many times for many different cases, there may be many matches. Another big challenge with record linkage is that we don't have any large-scale and realistic ground truth datasets. So what I mean by that is smaller datasets which are labelled to tell us which records really do match. If you've got those sorts of datasets, they're really useful because they help you to understand the accuracy of matches, and they also help you to calibrate your estimation models. And finally, there are a number of challenges associated with what's called the transitivity in your record links. So what that means is, let's say you have a record A and it links to record B, and then you find out that record B links to a third record, record C. That seems to imply that record A must link to record C, but that's not necessarily the case. So sometimes we have to do fairly sophisticated things with graph theory to try and resolve those transitivity issues. So what was our approach? Well, we started with a literature review and desk research into data linking theory and also practice. And what we found was one of the most common theoretical approaches described in the literature is the Foleggi-Sunter model. This is a statistical model, and it's got a long history of application for high-impact record linking tasks. So it's used at the US Census Bureau, and it's been used at the UK Office for National Statistics. And one of the really key benefits of the model is explainability. The model uses a number of parameters, and each of the parameters has got a fairly intuitive explanation that can be understood by a non-technical audience. So the relative simplicity of the model means that it's easier to understand and explain how biases in linkage may occur, such as varying levels of accuracy for different ethnic groups. There are more sophisticated models out there in the recent literature, and they probably have higher accuracy, but that comes at the expense of higher complexity, lower explainability, and often longer processing times. In addition, the potential for improvement in accuracy over the Foleggi-Sunter approach is probably relatively modest. So after settling on the Foleggi-Sunter approach, the team reviewed the available free and open source software that could be used to estimate the model. And we concentrated on packages which are available in R, in Python, in Apache, and in Apache Spark, because these are the tools which are available to us as analysts in the Ministry of Justice. And after looking at this software, we concluded that there are some really good packages out there, but they're not fast enough to use at the scale of data that we have at the Ministry of Justice. So we decided to develop a new software package that would underpin all of the data linking and deduplication that we're doing for the Data First project. And this new piece of software is called Splink. So what are the aims of this new piece of software? First is we want it to work at much greater scale than current open source implementations. So we want it to be able to link and deduplicate record sets at up to 100 million records or even more. We want to get results faster than current open source implementations. So we're looking to get runtimes of less than an hour, even for large record linkage problems, and speeds considerably faster than that for smaller problems. We think it's really important to have a transparent methodology so that our match scores can be easily explained both graphically and in words. And we want to make sure that the linking has accuracy which is similar to some of the best alternatives, either open source or commercial. We want to give our linked data users access to link confidence so that they can perform sensitivity analysis on their links. And we wanted to make sure that the software has got considerable flexibility and customizability so that it's able to tackle the majority of record linkage and data deduplication problems. And finally, we wanted to make sure that the software is really robust. So what I mean by that is that it gives the correct answer in the sense that it estimates the parameters correctly. And to make sure that it does that, we've got an automated suite of quality assurance tests that run a whole bunch of different checks on the software to make sure that the results are as expected. And I want to pick up on one of these points in particular. I think one of the biggest advantages of Splink over our historical approach to record linkage is that it gives us access to a link score, which is a way of quantifying our confidence in the match. Specifically, for each pair of records which are being compared, Splink computes a score which tells us how confident we are that these two records represent a match. So for instance, we might have lower confidence that two records represent a match if the people in question are both called John Smith, which is a very common name, relative to say if they were both called Robin Linacre, my name, which is a relatively unusual name. And I think this is especially important because it really helps to clarify what it means to do record linkage. It makes it clear that it's a process of statistical estimation and that there's always uncertainty in the process. You can rarely be 100% sure that two records represent a match. So rather than sweep this uncertainty under the carpet, it's good to make it really explicit. So this helps us to measure the accuracy of record linkage, and specifically it allows us to understand how many false positives or false negatives we might expect, and the trade-off between the two. It also enables new applications such as sensitivity analysis on research results, which we hope will enable researchers to ensure that their results are robust to the data linking methodology. So we don't want small changes in how the data are linked to cause big differences in the research results that researchers are getting. And we would expect that sensitivity analysis would enable them to build confidence in their results. We also hope that these scores can be used to better measure any potential biases in data linking, for instance by considering whether the average link confidence differs, say, between different ethnic groups or people of different other protected characteristics. And we're currently working on how we can make this information easily available to the end users of the data in a way which is easy to use, clear, and accurate. So I think a key point to mention is that the software is very, very general. It's been developed in a way which is in no way specific to the justice domain. And nor is it specific to a particular type of data linkage. So it can help link data sets, whether the entities in question are people, companies, addresses, court cases, or really anything you can think of. And it's also general in the sense that it's able to link and deduplicate an arbitrary number of data sets. So you're not just limited to linking two data sets to each other. And this sort of, the general nature of the software was a big factor in motivating us to want to open source the software and make it free for other people to download and use. And there's links on this slide that if you access them, you can find the documentation for the project and you can download and try the software out for yourself. And this is an area where we're really keen for collaboration. So if you'd like to try the software, please do let us know if you have any problems or you have feature requests or you'd like to contribute. And in fact, we found open sourcing the tool very useful. We've already been collaborating with the Office for National Statistics, and for instance, they've helped us to quality assure the work. So far, we've used the software to deduplicate our Magistrates Court dataset, which is one of our biggest datasets, and there's currently work in progress to deduplicate and link Crown Court data to Magistrates Court data. So this leads me on to the obvious question, which I hope a lot of viewers will be interested in, which is how do I gain access to some of this data? So our first dataset of Magistrates Court data has been made available on the Office for National Statistics Secure Research Service already. This is a large dataset of over 12 million cases in the Magistrates Court between 2011 and 2019, so that's one row per case. And we've set up a website that includes further details of what the data contains and how to gain access to it. So at the link on this slide, you can find a full data dictionary that you can use to understand what fields are contained in the dataset, and there's also detailed instructions for how to apply for access to the data. So just some brief conclusions to finish up. The Data First project is unlocking the potential of the Ministry of Justice's data by improving the quality of the data and making the data available to researchers. And as part of this work, a new piece of free and open source data linking software has been developed called Splink. The first dataset from the Magistrates Court has been released and is now available via the ONS Secure Research Service, with more data to follow. Finally, I'd just like to say how grateful we are to ADR UK for providing funding for all this work. That's it, and thank you for listening.